Now we want to solve the discrete time state space representative. What is the closed form solution of the differential equation about the xk plus 1 equal to jxk plus huak? We have two methods. One of the method is by inductions. Another method is using the z transform to find the xk. Okay, first inductions. Induction just only you put the first k equal to 0, you find x1 equal to jx0 plus hu 0. Then you increase the k equal to 1, then x2 is equal to jx1 plus hu 1. And I know the x1 is equal to here. Substitute the x1 in this equation. You can find the g2 x0 plus gh ua0 plus hu 1. And if you put the k equal to 2 and substitute the x2 by the second equation, you will find the g3 x0 g2 hu, and if you extend this one, you will find the xk can be found by the gk. x0 is a initial condition plus sum of the j from 0 to k minus 1 ga k minus j minus 1 hu j. And it's normal. The gk xk depend about the initial condition, and this sentence depend about the input, because if you see all this u1 this about input and this about the initial value. Solving by the z transform, if you know about xk plus 1, the z transform of here become zx0 minus zx0. Here become gx0 plus huz, and shift the x0 to the left side and here to the right side. Factors about the xz, and you can find xz equal to zi minus j inverse zx0, zi minus j minus 1 hu z. And if you see this depend about the initial condition, that means the same as the gk, and this one related about the input exactly the same as the sum of the j from 0 to k minus 1 gk minus j minus 1 hu j. Both method is similar together. Now with the one example, find the closed form solution of the state space system of xk plus 1 a b 0 c xk plus 0 1 u k. And they said the u is a step and the initial condition form is 1 and 0. We need to compute about the gk, and the eigenvalue of the g, you can write the lambda equal to a and the lambda 2 equal to c. Eigenvector for the lambda is equal to x1 1 0, and the lambda 2 become x2 become here. And I can suggest you a little bit study about the eigenvalue and eigenvector. Change of the basic matrix, and the P will become the 1 0 eigenvector, and another one become 1 C minus A divided by P. If I find the P inverse, become B C minus A, and just only the derivative of this system and this will be changed by the together, and here will be changed by the inverse negative value. G become, if you remember, become P D P minus 1, and the D, as you know, become the eigenvector. Gak become p dak p minus 1, and the dak will be the eigenvalue power k, eigenvalue power k. Okay, then you can find the g. I can repeat again, for finding about the g, you must find the eigenvalue and eigenvector. You find the p first, then you can find the g. The g become p d p minus 1, and the gk become p dak p minus 1, and the d is they need a eigenvalue. Okay, then easy. You can find the gk x is 0. I know about the gk, multiply x is 0, I can find here. Sum of the j is 0 to k minus 1 gk minus j u hj become p. Sum of the j equal to 0 k minus 1 d k minus j minus 1 p minus 1 h, because I substitute the j by the formula of the p d p minus 1 p d p minus 1. P can come out of the sum, and the d become k minus j minus 1 p minus 1. First I want to calculate about this part. First, about the sum of the j equal to k minus 1 d k minus j minus 1 is equal to sum of the j equal to 0 k minus 1 d j, and I know about the d is the eigenvalue. Sum of the eigenvalue become sum of the lambda 1 j and the lambda 2 here, 2j. I put the eigenvalue of the system here and eigenvalue about the second here. Then g k minus j minus h u j, I multiply by the input value. In the final, you can find the x